Welcome back to the gretl Instructional Video Series. In this video, we will be learning how to use gretl to perform the Engle-Granger Cointegration test and estimate an error correction model. The only file you will need to follow along with this video is Crude price. The three items covered in this video are as follows. First, we're going to look at the Engle-Granger Cointegration test. Next, we're going to estimate an error correction model. Finally, we're going to discuss several helpful gretl resources. Now, let's open gretl and get started by discussing the dataset. The first step is to open the data series Crude price. To do this, click on File, followed by Open Data, and then User File. Now, locate the file. Once located, double-click to open the file. This dataset contains two series. The first series is the Western Texas Intermediate crude oil price and is abbreviated WTI. The second series is the Brent crude oil price. These two series are the two leading crude oil benchmarks. Both series contain daily data from Monday through Friday and run from 2009 through 2011. Let's create a time series plot of both of these variables on the same graph to see what the series look like. To do this, left-click on the price WTI and select both data series. When you release the left-click, both series should be highlighted in blue. Now, right-click on the blue area and select Time Series Plot from the menu. Since we want them to be plotted on the same graph, select On a Single Graph. Once you click OK, the graph will open. As you can see from the graph, both series are trending upward and do not seem to deviate far from each other. It is plausible that the series follow a long-run equilibrium relationship that they tend to return to over time. Let's perform the Engle-Granger test for cointegration to find out. There are 4 steps to performing the Engle-Granger test for cointegration for two variables. The first 2 steps are to determine D for the first series and the second series. D represents the order of integration and is abbreviated ID. Recall that D is the number of times a series has to be differenced to be made stationary. We are going to use the ADF unit root test to determine D. The third step is to estimate the Cointegrating regression. The last step is to perform the ADF unit root test on the residuals from the Cointegrating regression to determine the order of integration. The null and alternative hypotheses for the ADF test are identical when performing the Engle-Granger test for cointegration, except that we follow different critical values, which are called the McKinnon critical values. The null hypothesis is that the series contains a unit root, which means they are not cointegrated. The alternative hypothesis is that there is no unit root, which means that the series are cointegrated. Now, let's go to the gretl main screen and complete the first step, which is to determine D for the first variable. We are going to use the ADF unit root test to determine D for the two crude oil price series. The null hypothesis for the ADF unit root test is that the series contains a unit root, against the alternative that the series does not contain a unit root. To perform the ADF unit root test for the first variable, click on the first variable so that it is highlighted in blue. Next, select Variable from the main menu, followed by Unit Root Tests, and then Augmented Dickey-Fuller Test. A window pops up that requires some input information. The first piece of information is for the lag order. As mentioned in the previous video, it is common to select the maximum lag order using the cube root of the sample size. We have a sample size of 504 observations, which has a cube root of 8. I always round up just to make sure to include enough lags. Next, we want to check the box Test Down for maximum lag order. The last input information for the ADF unit root test is to select the version of the test. From the plot, we know that the series have an upward trend. This means that we want to select with constant and trend from the drop-down box. Make sure to leave the default selection of Use Level of Variable. Now click OK and the output will open in a new window. The p-value for the ADF unit root test is large, which means that we fail to reject the null hypothesis. This means that the series needs to be different to make it stationary. Now we have determined that d is equal to 1 for the first series. To complete step 2, we follow the same method as in step 1. To save some time in the video, I am just going to show you the ADF unit root test output. For the second series, the p-value is also large, so we fail to reject the null hypothesis that the series contains a unit root. This means that the series needs to be different to make it stationary. Now we have determined that d is equal to 1 for both series, so we can move on to the third and fourth step in the Engle-Granger cointegration test. The next step is to estimate the cointegrating regression using the WTI crude oil price as a dependent variable. We can continue to this step because both variables are integrated of the same order. We are going to use the WTI crude oil price as a dependent variable and the Brent crude oil price as the independent variable. After estimating the cointegrating regression, we can move to the fourth step, which is to perform the ADF unit root test on the residuals from the cointegrating regression. If we reject the null hypothesis of a unit root, the series are cointegrated. When performing the ADF unit root test on the cointegrating regression, we will use the critical values specified by McKinnon. Let's go back to the gretl main screen to perform steps 3 and 4 in the Engle-Granger test for cointegration. To perform the Engle-Granger test, select Model from the main menu, followed by Time Series, then Cointegration Test, and finally Engle-Granger. A pop-up window opens that requires us to input some information. Under Variables to Test, select WTI first, followed by Brent. The variable that we select first is the dependent variable in the cointegrating regression. Now, input information for the ADF unit root test. This is the same as the leg length in steps 1 and 2, so enter the value 8. Next, we want to check the box Test Down from Maximum Leg Order. We will also check the last box because we have already performed the ADF tests. Now we are ready to click OK and the output will open in a new window. The output includes several pieces of information. The upper portion of the output contains the output for the cointegrating regression. We are interested in the lower portion of the output that contains the p-value for the Engle-Granger test for cointegration. If we fail to reject the null hypothesis, the series contains a unit root, which means the WTI and the Brent crude prices are not cointegrated. If we reject the null hypothesis, the series does not contain a unit root, and the WTI and the Brent crude oil price are cointegrated. In this case, the p-value is small, so we reject the null hypothesis at a 5% level of significance and conclude that the crude oil prices are cointegrated. This means that the series can be written as an error correction model. Here is the equation for the error correction model that we will be estimating. The lagged residual from the cointegrating regression is found within the curly brackets and captures the departure from the attractor from last period. The coefficient gamma is the speed of adjustment. If it is not statistically significant, the variable is weakly exogenous. Before estimating the error correction model, we must estimate the cointegrating regression and save the residuals. Let's go back to the gretl main screen to do that now. On the gretl main screen, select Model from the main menu, followed by Ordinary Least Squares. Now, select WTI as a dependent variable and Brent as the independent variable. Click OK. Notice that the coefficients are identical to those for the Engle-Granger output. Now, save the residuals by selecting Save from the menu, followed by Residuals. Call the residuals E and give them the description Residuals from Cointegrating Regression. Now, go back to the gretl main screen so that we can estimate the error correction model. Before estimating the error correction model, we must create two new series that are the difference of the WTI and the Brent crude oil price. To do this, left-click on WTI and drag down so that both WTI and Brent are highlighted in blue. Release the left-click and right-click on the blue area. Select Add Differences from the menu. gretl renames the differenced variables to be d underscore followed by the original variable name. To estimate the error correction model, select Model from the main menu followed by Ordinary Least Squares. Next, select d underscore WTI as a dependent variable. The independent variables are d underscore Brent and e. Next, we will add the legs by selecting Legs. In the window that pops up, we can select the number of legs, including the dependent variable. For the variable d underscore Brent, select legs 1 to 1. For the residual from the Cointegrating regression, select legs 1 to 1. Finally, check the box that says legs of dependent variable. Also select legs 1 to 1. Now click OK. In the model specification window, you will notice that -1 has been added to each of the independent variables. This means that the variable is lagged by 1. There is one last step before estimating the regression. Since we included a constant in the Cointegrating regression, we must remove the constant from the error correction model. To do this, left-click on Constant under the independent variables, and then click on the red arrow pointing to the left. Now, click OK and the coefficients for the error correction model open in a new window. The variable that we are interested in is e. In this case, the variable is not statistically significant. This means that the WTI crude price is weakly exogenous and does not move to restore the equilibrium with the Brent crude price. At least one of the variables must not be weakly exogenous if the series are cointegrated. There are three primary resources that can be used to find out more about the tests and functions in gretl. The first two resources, the user's guide and the command reference, are available from selecting Help off the main menu in gretl. They provide information specific to the functions in gretl. The third resource is a free ebook that you can find by searching the title in a search engine such as Google. It provides more general information than the first two sources. Now, let's move on to the 3 key points to remember. The first key point to remember is that the Engle-Granger test is similar to the ADF unit root test, except it uses critical values by McKinnon. The second key point to remember is that at least one of the series must not be weakly exogenous if the series are cointegrated. And third, there are 3 key resources that can help you learn how to use gretl to perform econometric techniques not covered in this video series. This concludes the 7th and final video of the gretl Instructional Video Series. I hope that you found this video series helpful and are now comfortable using gretl to perform econometric techniques.